Good evening to everyone. Now I want us to solve these past questions. Second cohort 2025. Algebraic thinking. So let's start with the very first question. Question 1. Devise a real world problem that can be modeled using a linear sequence and explain how you will solve it. So we are focusing on linear sequence. So I am going to model 3, after which I will only solve 1. I will explain how to solve it. So let's start. All these are models. You can pick one. Now let's see the first one, UCC shuttle fare savings, monthly budget. So this is the question or the scenario. A UCC student decides to save money by walking to the main entrance instead of taking the campus shuttle. They begin the year with 20 Ghana cedis in their savings box. They save the 1.5 Ghana cedis shuttle fare. So it means that the fare was 1.5 Ghana cedis. So they save that fare every day they walk. The sequence, so this is a model, and this sequence models the total amount saved each day. So here you can see that the initial term A1 was his amount 20 Ghana cedis. Initially he began the year with 20 Ghana cedis. That was the starting balance on day 1. Then because he works, he saves every day 1.5 Ghana cedis. That becomes the common difference, constant daily savings. And your nth term, that's the sequence, represent the total savings after working for n days. So you can model the sequence. The starting point is 20. Then you keep adding. You keep adding 1.5 to 8. So you can get a sequence like this. We will come back to solve this because the question said we should also solve it. But this is just the model. That is one model. I want to give you 3 so that you can choose one of them. We will come back to solve the problem. Now the second one is the scenario. A UCC student borrows a textbook from the Sam Jonah library. The initial late fine of the first day is 3 cedis. The fine increases by an additional 0.5 Ghana cedis for every subsequent day the book is overdue. Now, this is also an arithmetic progression, linear sequence. The sequence models the total fine due after n days. So the initial term was 3 Ghana cedis. That was the initial late fine on the first day was this. Then the common difference, the fine increases by an additional 0.5. So that is going to be your constant daily increase of fine, which is 0.5. Therefore, we can model a sequence, an AP. The nth term represents the total fine after n days. So as you start with 3.0, you keep adding 0.75 as the common difference. Now we can take the third one. In fact, I modeled or using UCC. You can change the model. A UCC student aims to reduce their weekly budget on food. They decide to reduce the number of scoops of rice they eat for dinner by 0.25 scoops each week. In the first week, they eat 5 scoops of rice. The sequence models the number of scoops eaten each week. So the modeling is initial term was 5 scoops, consumption in a week. Then the common difference was negative 0.25 scoops. That was a constant weekly reduction. Now, so the negative represent reduction. Sequence AN represent the number of scoops consumed in a week. And we can model the sequence starting from 5.0. We keep reducing by the common difference 0.25, and it goes on like that. Now let's go back to the first question and solve it as the question demands. So a UCC student starts with savings with 20 Ghana cedis. They save the 1.5 Ghana cedis shuttle fare every day. They walk to the main gate. How much money will the student have saved after 20 days? So here we are looking at U20 of consistent walking. So now let's start. Modeling with linear sequence formula. The formula for the nth term of a linear sequence, as you know, is AN equal to A1. Normally we use U. It doesn't change anything. So UN is equal to U1 or A plus N minus 1D. Now you identify the variables. We know that our AN is the total amount saved after N Ds. That is your nth term. Your A1 is the first term, the amount saved on D1, initial term, 20 Ghana cedis. Then the difference is the constant daily savings, 1.50 Ghana cedis. Then the N is the number of days, the term number, so the number of days. In this question, it is 20. So we just substitute the known values into the formula. You can do that, substitute them into this, and simplify your A20, that is 48.50. So this means that after 20 days of consistently working and saving the 1.5 Ghana cedis shuttle fare, the student will have saved a total of 48 Ghana cedis, 48.50 Ghana cedis. So that is one model of linear sequence. Let's go to question the B part of the question. Now the B part of the question says that create a new linear sequence where the common difference is a negative number and explain its significance in a real life. Now you can see that here the common difference was negative. Was it negative? Okay, the common difference was positive, so that is correct. So now we want to model a negative common difference. So let's take this question. A final year UCC student, in fact I have used UCC throughout. That doesn't mean you are mandated to use UCC. You can change the model. A final year UCC student takes out a student loan of 5,000 Ghana cedis for accommodation and fees. The repayment plan requires them to pay 150 Ghana cedis every month once they graduate. We want to know the remaining loan balance after they have made 12 monthly payments. So now the modeling is this. This problem is modeled by a linear sequence because the amount being reduced, that is, the amount being reduced, the repayment is constant each month. Remember the question said that a repayment plan requires them to pay 150 Ghana cedis every month. So it means that every month you will be reducing the principal by 150 Ghana cedis constantly. And that models a linear sequence or an arithmetic progression. Now the formula for the nth term of a linear sequence is this, as you know. Now we know our first term or the initial term. This represents the loan balance after the first payment. Now I need to explain something. So here our A1, the A1 represents the loan balance after the first payment. Now you can see that the starting amount, the principal was 5,000. So if I should start with This 5,000 normally we call it A0, the initial amount is 5,000. Now remember that we are reducing by 150. So when we reduce the 5,000 by 150, we get A1. And A1 is going to be 4,850, right? Good. 4,850. Then we keep reducing A2, A3 in that order. Now we are going to reduce up to A12. A12. Now let's watch something. The question says that explain its significance. So based on this question, remember the question is asking us to we want to know the remaining loan balance after they have made 12 months payment. So we want to see the loan balance after 12 months. Let me explain something for clarity. Now, if we should start with this, remember that this is the principal. So at the end, at the initial amount was 5,000. So we can say that at the end of the first year, we had this. At the end of the first year, we will get this. You started with this. Then you came to this. So it means that we are using this one. Your starting amount was this. At the end, you had this. So this A1 becomes the end of year 1. The end of year 1. Is that right? Then we move on. So remember that we are going up to year 12. So the end of year 12 is going to be A12. That is when you start from end of year 1. So end of year 2, end of year 3. Then this becomes end of year 12. So we are supposed to start from this amount as our A1. If we use A1 as this, the result will be wrong. Because at the end, there is no reduction. The initial amount has not received any reduction. So we cannot start A1 from here. Are we okay? So always, whenever you are modeling or the application of linear sequence, our A1 is when you have done your first subtraction. However, you can still start with the 500 as your A1. But if you do that, then it means that we are going to call A1 as the amount at the beginning of the first year. So if this is the amount at the beginning of the first year, then it means that the amount at the end of the first year becomes this, A2. So it means that A2 becomes end of first year. Then A3 becomes end of second year. Then so in that order. So it means that the end of the 12th year becomes A13. So it means that when you start from this, your n is supposed to be 13. And n equal to 13 means that end of the 12th year. Let's get that clear. So since the question is talking of after they have made payment of 12 months, so we are looking at the amount at the end of 12 months, there are two ways of solving it. When you start with this, n of 12th year, you use n to be 13. But if you start with this, then n of 12th year, you still use n is equal to 12. These are two ways of solving it. The formulas are the same. The only difference is that if you start with this, you use n is equal to 13, which is the same as n of 12 here. But if you use n is equal to 12, then it means that you have to first subtract the common difference to get A1. So you start with A0, then here will be A1. That is just the basis. So now let us start. So our initial term, we are defining our A1 to let the A1 represent the loan balance after the first payment. So we have to subtract the first payment, which is 150 from 5,000 to get this. Then we call this one our A1. So because now we have this to be our A1, since we are looking for after 12 months, we will use n to be 12. So our common difference is still the same as the 150 Ghana cedis. But remember, we are reducing we are reducing, so the common difference is supposed to be negative 150. Then the target term n, we are looking for the balance after 12 payments. So our n is equal to 12. Substitute the values into it as you know. Then you solve. So it means that after 12 monthly payments, the student's remaining loan balance will be this, 3,200 Ghana cedis. So we are done with this. But the question said we should explain the significance of this negative common difference. The negative common difference, D, equal to negative 150, has profound significance in the real life application. So some of the importance or the significance are this. It represents decrease. Negative common difference means decrease or reduction, depreciation. In the mathematical modeling, a negative common difference signifies linear decay, depreciation, depletion, or reduction. In this case, it signifies the loan balance is steadily decreasing. Then constant reduction rate. The value of negative 150 tells us the rate of change is constant. The amount the student pays off the principal loan is the same every month and it is reducing. Then the predictive power, time to zero. This negative rate allows for a clear prediction of when the quantity will reach zero. The model can be used to estimate exactly how many months it will take the student to fully pay off the total principal 5,000 Ghana cedis loan at this constant rate. So it means you keep reducing till you attain zero. The sequence generated, so that is all. That's the significance. So you can keep reducing this. You can keep reducing till you attain zero. When you get zero, it means you have paid off your loan. So that is the significance of the negative common difference. Now let's go to question 2. Question 2. A scientist observes that the spread of a virus follows an exponential sequence. Analyze how the number of infected individuals could be predicted over time. So a scientist observes that the spread of a virus follows exponential sequence. So here too, a model of exponential, that is geometric progression. We are to analyze how the number of infected individuals could predict over time, 10 marks. Now the mathematical model, the spread is modeled by an exponential sequence, geometric progression. Now, normally in science and in virus infection, we use the infection rate as I. Now we know that our normal geometric progression is supposed to, the nth term, un, is supposed to be ar n minus 1. Normally it is general that under virus infection we use the spread rate as I. So instead of u, I am using I. Then the number of times, here we use t to represent, because we are looking at time, the time it takes for the virus to spread. So instead of n, we use t. So it should be equal to I0, that is the first term. We are just using I0 to represent the first term. Your common ratio is still constant. Then it is supposed to be n minus 1. Or here, since I use t as n, it will be t minus 1. So it will be something like this. But remember that the same explanation I gave earlier, if you start with I0, then it means that we must increase the terms. We increase the terms. So remember, for the example I was explaining, when you start with 0, it means you are going up to 13. If you start with 1, you are going up to 12. So what is 13? 13 simply means that Or let's come to 12. I1 simply means that 13 minus 1. So that is the reason why in this, remember that always we start with n is equal to 1. That is why we have the exponent n minus 1. But here, normally the observed time, the very first time you see the virus or you see the spread is classified as an observed period, I0. So once you are starting with 0, it means that here is supposed to be 13. I'm using the concept of 12 and 13. Remember that 13 simply means you add 1 to the 12. So if the n minus 1 is 12, 13 means add 1 to 8. So when you add 1 to 8, the negative 1 will cancel 1, then you get back t. So it means that the formula becomes un is equal to ar to the power n, since we are going to start with n is equal to 0. If we start with n is equal to 1, the formula is ar n minus 1. So let's get the difference. So that is the reason why we are using this formula. So we have, let me clear this. So back to the question. Our IT, that's the nth term, IT is going to be I0, that is your A, times the common ratio exponent, the T, because we are looking at time. Good. So where your IT is the number of infected individuals at time T, I0 is equal to the initial number of infected individuals. So the very first time, those who were infected initially is represented as I0. Then R becomes the growth factor per time. Now since it is a spread, the question talks about a scientific spread. It is talking about spread. So it is going to be multiplied. So it means that your common ratio will definitely have to be greater than 1 for it to be multiplying exponentially. So R is supposed to be greater than 1. Then T is equal to the number of time periods. Example, days, weeks, and so on. So that is the formula. We are just applying the exponential sequence. Now, derivation of the formula. In each infected person, if each infected person infects R new people per time period, and it means that at the very initial, where T is equal to 0, I0, that is the initial number of infected individuals, will be this. Then at T is equal to 1, then it means that those who will be infected is going to be the initial times R. That is the growth factor per period. Then at T is equal to 2, we have to also multiply the growth factor, which is still R, by this. So we keep multiplying by R, just like we have this. If you have initial to be A and your common ratio is this, you first multiply by R to get AR. Then you multiply R by this AR again to get AR squared. You multiply R by AR again to get AR cubed. So that is exactly what we are doing here. So starting with I0, you multiply by R to get I0R. You multiply again by R to get this. Then you keep multiplying. So when you multiply by 10, that is the general, you get I0 dot RT. And that is what we have there. Now this is the explicit form of the geometric sequence. The explicit form of the geometric sequence. So you are getting I0, I0R, I0R. So where I0 is becoming the first term. Here our first term is the initial point, I0. And it goes on like that. Good. Now, the step 3, to predict future. Remember, we are using it to make prediction. So remember that we collected data. Then we record infected count at regular intervals. So we had day 0. Let's say we are just giving an example. So let's say day 0 is 10, day 1 is 30. So day 2 is 90. So it means that we are multiplying each by 3. So it means that the common ratio is 3 here. So you determine R. Or if it goes on like this, you can determine R by dividing D1 by D0 or D2 by D1. That is IT1, T1 plus 1 over IT. So if T is 1, you have T2 over T1. Or if T is 3, you have T3 over T4 over T3. Or if T is 2, you have T3 over T2. It is just a year after over the next year. So for example, if this is day 1, day 2 over day 1, day 3 over day 2, that is how come we are getting this. So it is just the normal way of finding common ratio. Good. So example, here we will have 30 over 10, or you can have 90 over 30. It will give you 3. Then you identify the initial I0. Use the earliest reliable count. So here in this one, it is 10. Then you formulate model. Now the model for the geometric progression is the IT, or UN is equal to AR to the power T. So IT is equal to I0 times R to the power T. You do your substitution, and you are going to get this. So you make prediction, you substitute. So it means that here you substitute future T into the model. So if they tell you that, let's say up to day 100, then it means that your T is going to be 100. If they say up to day 53, then it means that your T is going to be 53. So based on this model, you can even predict. So for example, day 5 means I5. It means you put 5 there. So this is the general model. Alright. So that is exactly, the question was just asking us to, where is the question? A scientist observed that the spread of virus follows exponential sequence. So just analyze how the number of infected person could be predicted over time. They didn't give you any question. So you are just modeling and explaining concept, how you will model this. That is so. Now let's go to B. A town's population is growing exponentially. If the population was 10,000 and the annual growth rate is 5%, analyze how long it would take for the population to double. I said double because 20,000 is just the double of 10,000. Alright. Let the population at the year T be PT. So when you see P sub T, it means the population. Now, given the initial population, so P0. So you realize that normally under modeling and application of GP and AP, we normally don't start with n is equal to 1. We start with n is equal to 0. And because of that, the formula normally changes. Whenever you start with 0, we don't bring the minus 1. I have explained that. I have already explained that. So the formula becomes, we know that the normal formula is going to be AR n minus 1, where n always starts from 1. But this time, we are going to start with UN is equal to ARN, where our first term, where A is equal to 1, but here where A is equal to 0. So anytime you start with A is equal to 0, the formula is being modeled like this. So our initial population P0 is equal to, did I say, I'm coming, where n is equal to 0, not 0. So when n is equal to 1, when n is equal to 0. Alright. Good. So our initial population P0 is equal to 10,000. Now we know that the annual rate was given in the question as 5%, which means that the growth factor per year is equal to 1 plus 0.5, which is this. This is going to be the common ratio. Now in the question, you were given 5%. the 5% is not your common ratio. Students make mistake. The common ratio is always 1 plus that. 1 plus that. Let me explain why. Now let's start with 10,000. Let's find 5% of that. That will give me 500. 5% will give me 500. It means that if I want to find my next term, it is going to be the 10,000 minus the 500. So that is going to be 9,500. Now let's find our common ratio. Our common ratio is going to be this over this. So 9,500 divided by 10,000. And let's see what you get. So divide by 10,000. And I am getting, oh sorry, I made a mistake. Remember the question is talking about if the population was 100 and the annual rate is 5%. So the population was increasing. So since it was increasing, let's rather add the 10,000 to the 500. So let's do that. It's going to be 10,500. So our common ratio is going to be the 10,500 over 1,000. 10,000 is going to be over 10,000. So 10,500 divided by 10,000, and that is giving me 1.05. So this 1.05 is the common ratio. Instead of doing all these, anytime you are given the 5%, the growth rate, you just have to, the 5% in the question was the growth rate. So if you want to find the common ratio, the annual growth rate, that is the common ratio, you add 1 to it. If you don't understand why, you can take it step by step like this, then you get your common ratio to be this. So that is it. Now let's continue. So we have our annual growth rate to be this. So that is going to be your common ratio. Your common ratio is that. So let's start. P1. Remember that P1 is going to be the population at the very first year. P1 is going to be 10,000 times the 1.05. Remember, we started with 10,000, and we are saying that the annual growth rate is 5%. And 5%, so it means that the increment, the percentage increment, is going to be 1.05, which represents the growth rate or the common ratio. So what do we do? When you multiply it by the 10,000, then you get the increment, you get the total population for year 1. So you multiply this by this, then you multiply, so it means that whatever you get here, you also multiply it by still the common ratio, which is R. So it means that here becomes 1.05 squared. Then you also multiply whatever you get here by 0.5 to get P3. So here becomes 1.05 cubed. So it goes on and on. So you can study the pattern and see that when we started with year 1, the exponent was 1. When we started with year 2, the exponent was 2. When we started with year 3, the exponent will be 3. So year 4 will be 4. So we can generalize that the population after some T number of years, we are going to have a total population of 10,000 times 1.05T. Are we okay? And the question says that we should analyze how it would take for the population to reach 20,000. So we can now apply this, substitute 20,000 into it to find P20,000. So this is the general term of an exponential sequence with A equal to 10,000 and common ratio of 1.05. Now we want to find PT equal to 20,000. Okay, sorry. So the question was rather asking us how long it would take for the population to reach this. So it means that we want PT to be equal to 20,000. We are not finding the population after 20,000 years, so we are not putting T 20,000, but they said we want to find the population. When will the population get to 20,000? It means that when will PT be equal to 20,000? So PT should be equal to 20,000. We already know that PT is giving us 10,000 times 1.5 to the power T equal to 20,000. We can divide through by 10,000. We will get this. Then here you can take log of both sides. I took natural logarithm, but you can take the normal logarithm, log of log 10 of 1.05 to the power T equal to log 10 log 10 to the power T log 10 of 2, like this. Then you know what to do. This T will come here, you divide through by. So that is one approach of solving it. The other approach is to use the natural logarithm, or even because here is 2, you can use log to the base 2, so that it will just cancel this to be 1. So whichever log to the base you use is correct. The natural logarithm simply means that ln simply means that log to the base e. That's just the meaning. So we are just finding log to the base e. But you can find log to the base 10 or whatever. Then you use it. You will still get the answer. So you will get T to be equal to ln 2 over ln 1.05. Remember that the exponent law says that this will come here to multiply. So T ln 1.05 should be equal to ln 2 divided through by ln 1.05. You have this. Now apply the calculator. Use your calculator. We know that ln 2 is this from the calculator. Ln 1.05 is this. Then we are dividing. So you get this. So it means that T will be approximately 14.21, or you can round it down to T is equal to 14 years. 14 years. 14 years. And that is the answer. So it means that in 14 years, the population will reach 20, or we can say that in about 14 years, the population will reach 20,000. Alright. Let's go to the next question. A number of clients who usually visit a restaurant by the name Carmen's were asked whether they liked rice, fufu, ampisi, or ampisi. Okay, so they were asked whether they liked rice, fufu, or ampisi. Now, 14 clients said they liked rice, 18 liked fufu, and 23 liked ampisi. Now, they wrote kinky, so let's change it to ampisi. Now, only 7 said they liked 3 foods. 7 clients liked rice and fufu, and this includes those that liked all 3 foods. 10 clients liked rice and ampisi, and 14 clients liked ampisi and fufu. How many of the clients liked rice only, fufu only, ampisi only, and rice or fufu or ampisi? So we can just model it. Rice was given as 14, fufu as 18. Then instead of kinky, it was ampisi. So ampisi was 23. I just put them in bars to mean that these values cannot be negative. When we talk of number, it cannot be negative. It has to be absolute. Now, so the intersection of all the 3 was 7. The intersection of R and F was 7. R and F was 7. So if R and F was 7 and all the 3 is 7, it tells you that here must be 0. Then R and A was 10. If R and A is 10 and here is already 7, then it means that here has to be 3. Good, so I've done the subtractions here. Then, so these are the onlys. So F intersection A, F and A was given as 14. If it is 14, and already we have the 3 intersection to be 7, then here has to be 7. So you subtract 7 from the 14 to get 7. So these are the onlys. Now, we are left with rice only, fufu only, and ampesi only, and that is what the question is asking us to find. Since we know 14, 18, and 23, it means that everything here has to be 14. So 3 plus 10, 3 plus 7 is 10, minus the 14, 4. 40 minus that is that. Here is 18, we have 7, 7, 14, minus this, 4. So we will also have here to be 4. Is that correct? Good. Then here is 23. We have 7 plus 7 plus 3. That will be 10, 17. Then we subtract from 23. So we have 6. So that is going to be the answers. That's going to be the answers. Then the R union F union A, add everything here. Add everything. Since you know this, this, and this, you add everything in the circle, then you get this. So that is using the Venn diagram approach. You can use the other approach, which I don't think you will use. Most of you prefer the Venn diagram approach. So, using the other approach, you have to write the set definition. So R only is equal to R minus R intersection F. That is exactly what I have done here. These ones. That's what I've done there. And you get 4. So that is going to be this. The first question was rice only. The rice only is what we call R only is going to be R, the total R minus R intersection F only minus R intersection K only minus the 3 intersections. So you see that if you are finding rice only, you subtract this, this, and this from this. And that is what we have done. So you subtract the total. So from the total, you subtract this, you subtract this, you subtract this, and you get this. But normally, some of you will find it difficult using these things. So fufu only is the same thing. So this presentation is just what we have done here. So once you use the Venn diagram, it is clear that you are subtracting this, this, this from this to get this. You subtract this, this, and this from this to get this. And the same thing applies here. Alright, then the last one was to find rice or fufu or kinki. That is what I said. You add all the 5. So 7 regions. Remember that the last part there was nothing there. So you add all the 7 regions to get that. So that is going to be R only plus F only plus K only plus this plus this plus this plus all the 3. You add everything, then you are going to get 31. You get 31. So that is the answer. Remember the question was asking us to find rice or fufu or ampesi. That will be 31. 31. Now let's go to the next question. Question 4. 1/4 of a herd of camels was seen in the desert. Twice the square root of that herd had gone to the mountain slopes. Okay. Had gone to the mountain slopes. After this, 15 camels still remain at a river bank located in the desert. What is the numerical measure of that herd of camels? So this is a very simple question. Very simple question. So now let's start with n. Let n be the total number of camels in the herd. And from the question, we said that some has gone to the desert, some was seen in the desert, 1/4 was seen in the desert, then twice, so 1/4 of the total, so 1/4 of n was seen in the desert. Twice the square root of the herd had gone to the mountain. So it means that twice the square root of n has gone to the mountain slopes. Then after this, we still have 15 camels remain at the river bank. So it means that we will still have 15 at the river bank. So we are adding deserts. Those who have gone to desert, we know 1/4 went to the desert. Those who went to the mountain, seen at the mountain slope is twice the square root. So twice root of n. Then those that were seen at the river bank were just 15, the remaining parts. So when you add all these three, remember that will give you the total n. So n, which is the total, should be equal to 1/4 of those seen at the desert, two roots of the total, which is n, then plus the remaining at the river bank, which is 15. Now, we can simplify it. Remember that we can take this 1/4n to the left-hand side to be n minus 1/4n, and that will give us 3/4n. Then the 15 will also cross the equal to sign to be minus 15. Then we are just left with 2 root of n at the right-hand side. Now, when we get to this point, there are two ways of solving it. I can square both sides and solve. I'll get n straightforward. But to make it very simple, we can let s be equal to the root, the set. Let s be equal to root of s. Square both sides, so you will get n to be equal to s squared. Now we are going to substitute these two back into the original. So wherever I see root of n, I'll put x there. Wherever I see n, I'll put s squared there. So I'll get 3/4 s squared minus 15 should be equal to 2 times root of n, which is x, 2x. Then I'll simplify. I'll multiply both sides by 4. So 4 here, 4 here, 4 here. I'll get this 3s squared minus 60 equal to 8x. Then you group like terms. So you get 3s squared minus 8x, then minus 60 equal to 0. Now you can solve using factorization if it will work. But for you to struggle looking for the factors and you are not getting, just go ahead. Remember, you can still use calculator to solve. You can use the calculator to guide you to get the factors. But why don't you use the formula? X is equal to negative b plus or minus root of b squared minus 4ac all over 2a. Your a is 3, your b is negative 8, and your c is negative 60. Substitute them into it and simplify. You will get x1. Remember, you have plus or minus, so you get two values. x1 will be 6, and x2 will be equal to negative 10 over 3. Now remember that we said let x be equal to root of n. If s is a square root number, square root of any number will give you a positive number. So it means that this x value can never be negative. It must always be positive. So since x is equal to root of n, it means that x must be positive. So among the two values, we realize that it is only 6 which is positive. This is negative, so x cannot be this. So we are choosing x to be 6. So it means that we choose x to be 6. Then we go back to this and substitute x there. So n is going to be s squared, which is 6 squared. Then n is equal to 36. Therefore, there were 36 camels, head of camels, originally. And that is the answer. Now the last question we are supposed to solve is mathematical induction. I will not get time to solve this because we have solved a lot of mathematical induction questions. So take your time and solve this question. Start with the base case where n is equal to 1. Then move on to the assumption stage. Assume that n is also equal to k and prove for n is equal to k plus 1. If all these three conditions hold, then it means that by mathematical induction, this statement is true. This statement is true. Good luck. Good luck. Good luck. Have a nice day. Bye-bye.